So hello and welcome back. In this video we want to do the section on finding equations of exponential functions. So basically we have already done this in the different examples that we have done before, but we can go over this one more time. So basically any sort of exponential function that you might come across is basically something like, for example, f of x is equal to a into b raised to the power x. So as you know, a is your initial value, and this is basically the value with which the function starts. And also this is also your y-intercept. So this is your initial value or the y-intercept of the graph of the function. B, on the other hand, here is your growth factor. So, for example, let me give you an example of course we have done this before, but just for the sake of explanation. For example, let's say you have some sort of wildlife population that has been controlled by man in some way, and for example you have a population of deer, for example. A population of deer, for example, let's say 100 deer have been introduced into some wildlife refuge at some point in time. For example, you have, let's say this is your t in years, and this is your, for example, the number of that population of animals over time. So for example, let's say in 2010 80 deer have been introduced to some wildlife refuge so that they can be preserved or taken care of or something like that. And then of course you know that animals reproduce, so their population, if everything goes right, the population is going to grow, let's say year by year. So in 2011 the population has grown to 80 times, for example, 1.6. So 80 times 1.6. Again, after 1 year in 2012, the population, this population that we had in 2011, which was 80 times 1.6, again has been grown by 60%. So I multiply the whole thing again by 1.6. So that basically means that after 1 year after 2010, the population has grown by 60%. Again, after 1 year, it's grown by 60%. And let's assume that the same thing has continued over time for some infinite period of time, something like that. So now here, because we introduced the population of deer into the wildlife refuge in 2010, I can take this as year zero. As year zero, that means no time has passed at this time, and the initial value of my function at this point in time was 80. So this is my initial value of the function. So the initial value of the function was 80, and this is, by the way, is equal to a, this a that you can see over here. And you know that the population has grown by a factor of 1.6. So this is your growth factor. So this is your growth factor. So that basically means that if you want to write the equation for this function, all you need to do is, for example, you need to just figure out what sort of function you're dealing with. So here, this is year 0, this is year 1, year 2, that means 0 years after 2010, 1 year after 2010, 2 years after 2010, and so on and so forth. So in 0 years after 2010, you can see that let's start with this. So after 1 year after 2010, you have this growth factor raised to the first power. In the second year, in 2 years after 2010, you have 80 times 1.6 raised to the second power, because you have two factors multiplied together. And in the first year, it is 80 times 1.6 raised to the 0th power. So you can see this 0 is the same 0, this 1 is the same 1, this 2 is the same, of course not the same, but they correspond to one another. So basically, that means that you could write the general form of this function as n of t, which is equal to 80 times 1.6 raised to the power t. So here your t was 0, so here you've then raised 1.6 to the 0th power. Here your t was 1, and then you have raised your 1.6 to the first power, 2 second power, so to the tth power. So that is basically the rule for this function, and this is in the form f of x is equal to a times b raised to the power x. This is your a, this is your b, and this is your variable here. So based on this kind of behavior, this general behavior of exponential functions, we can figure out we can figure out what happens in different situations, and then based on that write find the equations of exponential functions. So let's go through an example here, but I think we can do the example in the next video. So I'll see you in the next video.